Quadratic optimization, example 1. We want to find the maximum or minimum values of the following functions and the corresponding values of x. Now later in the course, when you do differentiation, you'll have other ways of doing this. For now, what we want to do is find the vertex, and that probably means we want to complete the square. So, for this one here, we know we could do x plus 2 all squared. Remember, the plus 2 comes from this coefficient. X plus 2 all squared, when we expand it, gives us x squared plus 4x, but it also gives us a plus 4. We don't want that. And then don't forget this minus 7. So that's x plus 2 all squared, take away 11. And that tells us the vertex, or turning point, is at -2, -11. And we know that this particular graph is a happy one because the coefficient of x squared is 1. So it's going to be a minimum. So we're going to have a minimum value of -11, and that's going to happen when x is equal to -2. So if we come across to this one here, I've got -2x squared plus 8x plus 3. Now the fact that the coefficient of x squared is negative tells us this time that we have a sad curve, and that means we have a maximum point. So take out -2, and then we'd have x squared, and we want to get plus 8, so if I put minus 4x here, and then don't forget the plus 3 off the end, if we re-expand, that does give me minus 2x squared plus 8x. So that's -2, and then in the bracket we have x minus 2 all squared. That would give me x squared minus 4x, but it also gives me a plus 4, which I don't want. And then don't forget this plus 3. And re-expanding, that's -2 x minus 2 all squared plus 8 plus 3. So -2 x minus 2 all squared plus 11. So the turning point here is at 211. And so we have a maximum value. Remember, this would be a maximum up here. So a maximum value is equal to 11. And that happens when x is equal to 2.